Hello everyone, this is Satasta Goswami and today I am presenting a new topic. We have already studied about the mathematical average. It is also calculated mid-value and it is determined by the average value of the series. Although through arithmetic calculation, so by the help of the arithmetic calculations you will find out that the calculation of the midway determines the average, and mathematical averages of several types. Okay, now we have arithmetic average. So it is the most popular and widely used measure of central tendency, and it is also called arithmetic average or simply mean. When we talk about the arithmetic average, you can also write AM. So it is popularly measured. It is popular. I mean that if you studied in the class 10th or in your junior book, the average is just mean that total number of observation divided by number of observation. So while calculating the mean, there are so many ways like GM, HM, AM, but mostly people use AM because it is easy to calculate, and layman even use this measure. And the other two, I mean the geometric and harmonic mean. So in order to calculate them, you have to get the knowledge about the statistic. It is not for all the peoples, so it is most popular and widely used measure of central tendency, and it is also called arithmetic average or simply mean. So you can also say that it's the arithmetic average or simply the mean. So here there is it is defined as a sum of value of groups of items divided by the number of items. So as I already mentioned that it is defined as the sum of values of the group of items. I mean the sum of the group of items whatsoever the items were there, and then you have to divide it by the number of items, whatever the number is. Let's suppose 30, 40, 50 is there, and the number is almost 5. Okay, so the number of items were 5, so it is the number, it is the sum of the values, because you are in the nominator you are calculating the values, so it is a sum of values of all the items, whatever the items is there. So it is the sum of the values of the group of items divided by the number of items. Okay, so it is defined as the sum of values of the group of items divided by the number of items. So mean is 1 by n and xi, where xi is the value of variable and n is the number of observation. So here xi is the variable, values of the variable, and n is the number of observations. Okay. Then we have types of arithmetic mean. So there are two types of arithmetic mean: simple arithmetic mean and weighted arithmetic mean, which is SAM and WAM. Okay, so simple arithmetic mean. So under such a mean, all the items of the series are given equal importance. So by the name also you can understand that this is a simple arithmetic mean, where there is no such weightage given to any kind of observations. Okay, but in the weighted arithmetic mean, there are some few items which is given more priority. But when we will study the simple arithmetic mean, so you can see that the number of formulas are more, and in the weighted arithmetic mean, all those formulas are very basic. Okay. Now we have list of formulas. So it is according to the series here. I know I'm very very sorry that whole formula is kind of look messy, but I'm gonna write it down and make it more clear. Right, I will write somewhere else. So let's begin with the list of formulas. So the formulas are here in the table. The formulas are composed by taking the two criteria. First is what kind of series is this, and the second one is what kind of method we have adopted. So there are three kinds of series: individual series, discrete series, and continuous series. And we have three method, which is actual method, which is a direct method, assumed method, you can also say shortcut method, and step deviations. Okay, so the actual method is what where we take the direct mean. I mean, in the observations there is one observation which is the exact mean of the um, table and of the observations, and where if you have taken the exact mean, then the deviation must be 0, and due to this the formula is kind of basic. And when you assume, so why you're assuming, if the mean comes into the decimal, so well you are calculating the decimal, so the calculations will be kind of complicated, and that is the reasons why we adopted the second method, which is assumed mean method and shortcut method. Here um, here a is mentioned that a plus sigma d by n. Here a is assumed. Then we have arithmetic mean here, and here is according to the series the formulas is like kind of change. In the individual series the frequency is not there, and in the discrete series frequency will be added, and in the continuous series in the place of direct observations mid value will be there, because the values is in the range, and you have to calculate it, and how you are calculating the mid values. So it is obvious that you are adding the upper limit and lower limit, and then you divide it and you get the value. And you can also add by the same interval as a range. And then we have step deviations, and in the step deviations you have to multiply it with the common factors, as it is written in the individual series and in the discrete series and even in the continuous series. You got it? So here it is like that. So first we will go through the individual series. So it is a summation x by n. So summation x is the total number of observation and n is the number of observations. Then we have the discrete series. In the discrete series frequency is added, that's summation fx by summation f. Then in the continuous series summation fm, in the place of xm will be there, and summations f is there. Then we have in the assumed mean a plus summation d by n, a plus summation f by d, f into d by summation f, and extra is a plus summation ft by f. Okay, then we have step deviations where a plus summations d by n, and only the change is common factor. So when you will calculate it, so in the place where you have to divide the common factor, if you are taking the common factor 2 or 5 something like that, so in order to compensate it you have to multiply it. Mathematics is all about LHS and RHS, not exactly, but if you have changed anything in the formula, so you have to compensate it and get the neutralized result rather than impacting due to your change. Okay, so we have already divided it, so here we will multiply. Then we have a plus summation f d by summation f into c, and d is there, then d dash is d by c. So here the formula is the same, and in the place of x there is a m minus a. So why a is added? Because when we assumed any kind of number, then we subtract all these numbers, and to order to compensate we added the assumed method. Okay, so here if you have doubt that whether your solution is right or wrong, so you can also check by the Charlier accuracy check. Here is for assumed mean method, summation f d plus 1 is equal to summation f d plus summation f. So it is the same, as you can see that in the left side, if you simplified it, so it is equal to the right side. Then we have for the step deviation method, summation f d dash plus summation f d dash plus summation f, and you can also write u in the place of d dash. So there is nothing in the place of d dash is there. And how d dash is calculated? D dash is equal to d by c, where you have to calculate the common factor, but in the formula there is no involvement of common factor. Now we will move to the determinations of SAM. So first we will take the example of the individual series. Here the marxes is there, then you sum added up, and what it gets, summation x, and then count the number of observations, which is 5, and put it in the divide form, and what you get 30 marks. Then in the assumed method you have taken the deviations like in the one numbers, and you calculate the deviations part. So and then you have assumed 30. So in the formula you have to write 30 plus 0 plus 5. So as we know that in the assumed method, the it is the exact value, so that is the reason 30 marks is there. But if any other number is there, like here 30 is the actual mean, but if you have taken any other, so it must be like different from the observations. Then we have a step deviations method. In the step deviation method you have to calculate the d dash, and we have calculated it. We have taken the common factor 10, and then we divide it. So well, after the division you get the formula. Then we have discrete series. So what is discrete series? So here there is a frequency, and rather than calculating the x summation, now you have to calculate the summation f, because counting the observation is not there. So you have to calculate the summation f and fx as well. So here's the formula is there, and you have to put it and you get the same. Then if you are calculating it by the assumed mean method, so what you have to do, you have to calculate here the direct observation is there. Now we have to calculate the deviation part. So here the x and f is there. Now take the deviations. Let's suppose you have taken the 30 only, so you get the this deviations and then multiplied it, deviations by f. Here there is no x observations, and while putting it you get 0, because this is the actual. Okay, so here you have put at the values and you get this. Then we have a step deviation. So what it do, so it calculate the by the d you have to calculate the d dash. So the formula will be say one step is further taken, where to simplify the d also there is d dash. where the formulas will be most short, and um, if the questions will be asked like the observations have bigger numbers, so accordingly use it. Like if the numbers are complex and big, so you have to calculate it by the step deviations or assumed method. But if the calculation is kind of easy, so you can calculate it by your you can calculate it by the simple methods uh like from the actual mean method also, if the mean is in the whole number. Okay, so here the mean is in the whole number 30, so it's pretty easy. And even if your raw number is not that easy, so it is better to take assumed method. And if the assumed method will not work, so it is a thing. So here the step deviations is completed, and then we have so after the step deviations, what we have to do? So here it assumed method, then we have then we calculate it. So you can also check by the Charlier accuracy test, where you have to put it like summation ft, and what is your summation f, and what you get the 40, and all the other are summation f, which is of course 30 plus 10, and which is 40. So here's the formula, is verified. Then we have what's uh, here the values is there, and you have to check it by the Charlier accuracy test. Then we have weighted arithmetic mean, where nothing else, like in the place of summation f, w is there. So summation wx by w is there, and in the place of frequency it is there, fx is there, and the formula is also the same, like it is the same as um individual series and like actual mean method. And then put it on the formula, where there are so many things, like mean is here. It is used to be noted that if the items of the series are aligned equal weight, then if the items of the series have the equal weight, then there is no such difference between the mean and the mean with weighted mean. I mean the simple mean or weighted mean have equal value, because all the values have given the same advantage. And when the items of the series have given different weight, if the items have given different weight, then of course mean is not equal to mean of the weight. So if it is not equal to, then what are the two circumstances? So when the items of the smaller values of the series are given less weight, and larger values to are given more weight. When there is like direct relation, where you are giving more importance to the larger value, less important to the lower values, unlike the unlike the harmonic mean. And Here, of course, weighted means value is greater than the actual mean, and when the items smaller values are given more weights and bigger values are given less weight, like in the vice versa. So, actual mean will be greater. Okay, so here, if the value of all the observation given the same value, so the mean and weighted mean have same values, and if like the values are different, like some of the items are given different weight, like different weight, so it's kind of like different weights, so it's like they are not equal, like that mean and the weighted mean, and there are two circumstances arise. In one, the mean of the weighted mean will be greater, and the second, the mean is the greater. So if the value or less value is given to the large value and large values are given less values, then it turned out. But if you are working on it, so it will gradually work. So here the greater values are there, like for the greater values given the more weight, or less values are given less weight, and vice versa. And here the direct thing is there, larger values are given more less weights, and more weights are given to the less weights, which government tries to do. I don't know what. Then there is one questions like there is a weighted mean, so here it is justifying the three situation. In one situation the equal situation is there, in the second both the situation not equal, in the one it is greater, and in the one not. So first, the in order to calculate the sum, just simply calculate the summation x by n and you get the 30 units. To in order to compare with it, so you have to calculate the sum, then bam, which is mean of the weighted mean, and the summation w1 by x by summation wx, and you get 300 by 30, which is 300. So here summation x is mean of the weighted mean, and if it is increasing, I mean the if the weighted mean is increasing, so what will happen? So here the values is there, okay, and this values is there. So if it is increasing, so if it is constant, like all the values are given the equal importance, then when you calculate the actual mean like sam or vam, so both will be the equal, because the weighted is constant, I mean there is no such advantage is given to any kind of students. And when the weighted mean are in the ascending order, okay, 1 2 3 4, so that means it is increasing, and it also means that weighted mean have greater value as compared to mean, which is the major criteria. So here the 15 is there, summation at 15, and you get the w2 by x because the frequency is now changed, and this much is the values. And then the weighted mean, here the third value is there, which is the from the larger to smaller, and here the all the values have written, and where the weighted mean have very much less values compared to mean. So it is a mathematical thing, so you have to get the proof and other stuff. So from next day, I will start on the mathematical properties of the arithmetic mean. Okay, and then we will move to the merit and demerits. Okay. Okay, so till there, take care, bye bye, and I'm just feeling sleepy. So, okay, so I will tune on the next day with a new topic, which is properties of the arithmetic mean, and we will also discuss the merits and demerits. Uh, so I will tune it because now I am just started getting off of my mind. So yeah.